Hello, class, the receiving students and teachers.
Hello, Mrs. Vargas.
You may be seated. Now, before we go to our lesson for today, I'd like to acknowledge Curacao Primary School in East Sepik Province. On behalf of the model teachers, I'd like to acknowledge you for what you have sent us. And acknowledgement goes to the students, the headmaster, and the teachers of Curacao Primary School. Thank you. We will keep this model of a canoe you have, and it will help us in the lessons that we teach later in the year. Thank you. Teachers, we are still on the same strand, science in the home, sub-strand using science in the home, and outcome 8.3.5. Now, as usual, class and the receiving students, I'd like us to recall to our previous lesson. Now, we looked at different types of levers. There are 3 different types of levers. And each of those levers, when you had a look at them, we had one part of the lever that had effort, one the load, and one the fulcrum. Now, I'd like someone from the class to tell me what an effort is on a simple machine.
It is the part of the simple machine where force is applied.
Very good. It's part of a simple machine, a lever where force is applied. Now, our next is also on simple machine. This time it's the load. What do we mean by load on a simple machine or a lever? Receiving students, tell your teacher the answer to that question. And let's have Patricia.
Part of the simple machine where load is loaded.
Very good. It's a part of the simple machine where load is loaded. Whatever you are going to work with is loaded. Thank you. Now, I'd like every one of us to stand up, class. We are going to do some exercise this morning. Out of your seats. Once again, we looked at different parts of a simple machine. We looked at the effort and where force is applied on a simple machine. We looked at the part where the load is loaded. We also looked at the fulcrum in the previous lesson. Now, class and the receiving students, different parts of our body also have, different parts of our body are also levers. They do have fulcrum. They also have a load, part of the body where load is carried or loaded, and also where force is applied. Now, I'd like the class, while standing in your groups, discuss quickly which part of a body you think has fulcrum or fulcrum, also effort, as well as load. Receiving students, you can do the same together in your classes. Together? We should be talking about it. Okay, thank you. Edward is going to show us some parts of the body that can be a lever that has effort, fulcrum, and also load. Edward, if you can show your friends and also your friends in the receiving class.
This one is load, fulcrum, and effort.
Okay. Okay, thank you, Edward. Anybody else who would like to show us another part of a body that has a pivot, a fulcrum, and also where force can be applied? Edward has shown us our hands. Okay, he said this is the pivot or the fulcrum. Okay, he said this is where the force is applied or effort, and he said where the load is loaded. Anybody else who would like to show us another part of the body? Receiving students, please, you also show your teacher another part of a body that has fulcrum or pivot. Daira, thank you.
The sole of our feet is where the load is. Our knee is the fulcrum, and our weight is the load. Effort.
Effort, very good. Thank you, Daira. Thank you, class. You may be seated. Class and receiving students, I'd like to show you on this seesaw balance that I have. Now, we have a balance here with us. I'm going to weigh this container of water on one side of the balance. Now, I have my load on one side of the balance. I'm helping to support this. There is something taking me to this hand where I have the load. If I can have Raymond to tell me why I have to hold this to support this load. Receiving students, you can tell your teacher.
To balance it.
To balance it. Thank you. Anybody else? That's another answer. Thank you. Okay, we have Edward.
To support the container from falling.
Good, thank you. To support the container from falling because it's too heavy. Now, what will I do, class and the receiving students, what will I do to make this container of water balance? Thank you. We have Violet.
Add the same load on the other end to make it
Have
balance.
the same load on the other side. Thank you. Okay, so Violet says to make it balance, I should put another load on the other side so it balances. Let's see. Okay, thank you. So whatever answer Violet has given us, we try to do that so we can see we are able to balance the balance that we have set up. Now, our lesson today is on levers, problem solving. We have some words to look at. The first one, it says load, and the second is effort. Class and the receiving students, I'd like you to look once again. Let's have our load up again. This is our pivot or the fulcrum. Now, the load is what we have here with us, what we are trying to weigh. That is the load. So it says load is the object to be moved. Now, in some cases, load, we either move it up or down, or we move it by pushing it to some distance that we need to, or pulling it. So load is the object to be moved. In here, our load is this container of water. Now, effort, it says effort is the force applied to move a load. That is our load. The effort, what we have seen earlier, we try to put another container of water to balance the ruler. So that is the effort tried to balance the ruler. Our effort was this container of water. We use that one as our effort to balance the ruler. We also have load distance. Load distance is the distance from the load to the pivot or the fulcrum. Effort distance is the distance from the fulcrum to whatever we have used to try to balance the ruler. In that case, we used a container, another container of water. First advantage, students in the receiving school as well as the class, all those terms that we are just looking at will be the terms that you will be using when you are doing the activity that we will be doing in this lesson. First advantage is the effort applied is less than the force produced. Now in here it means whatever effort that you apply or the force that you apply to move an object, if that force is less, then that force has an advantage on whatever mass or whatever load you are trying to move. Now in this lesson, class and the receiving students, we will be using one of our simple machines, which is a balance, a spring balance. And for us to see how useful this machine is and how we want to know how much work that machine can do to help us in balancing the ruler or whatever that we have to use. The formula used in there, it says mechanical advantage equals load over effort, or MA equals load over effort. Mechanical advantage is actually talking about using machines, how we can make things easier, or how machines can help us to do whatever work that we have to do, especially in lifting whatever loads that we have to work with. Now our activity for this lesson we are going to be using the strategy group work, and in this activity we will be using a load of 500 grams, and the distance from the load to the fulcrum is going to be 25 centimeters. Now I also have the results table up, and that is the table that we are going to be using, activity results table. As teachers in the receiving schools, I'd like you to take note of that activity results table so the students can use that. That activity results table is the table that you will be using once you do the experiment. Whatever you find out, you enter it onto that activity results table. Now, once you get the table you are going to be having 3 attempts. In the first attempt, we are still using the same load, which is 500 grams. Now, in the first attempt, your effort distance, that will be 12.5 centimeters. Your second attempt will be 25 centimeters, and the third attempt is going to be 50 centimeters. Now, for you to find the force to balance the load, as we go through the activity, you will know what to do to find the measurement or find a force that can balance this load at this distance. And the mechanical advantage, you will use the formula we just had a look at earlier in the lesson. Now I'd like the class, the runners to come up and get your materials quickly. Yep, get those ones. Help me give us the worksheets. Yeah, one to everyone. And here, this one, just, it's already there, leave it. Get them quickly. No, leave that one. Now check to see that you have one container of water, a spring balance, 2 paper clips, a ruler, a 1 meter ruler, and a stand where you will hang that ruler. Now instruction, you are to use a paper clip to hang the 500-gram mass at 25 centimeter mark on the ruler from the left side of the fulcrum or the pivot. You should be all doing that now, the first step. We will be going through together, step by step, for you to do that activity. So everybody should be working on that, the first activity. Now the third instruction says, to get the reading, pull the spring balance down slowly till it balances the load. Okay, so you don't hold it, Okay, once it balances, then what's your reading now? What's your reading? 10 Newton. Okay, that's your reading. So see, that's where you write it. And did you get your first reading done? Yeah. What did you get? Okay, good.
No, one
This pivot is not in the right place. Hold it first, hold it.
Wait.
420, 440, 460, 489.
Okay. Pull it down. Now you are to do the same with the next two effort distance. That is the 25 centimeter and 50 centimeter. How you have gone through to get your effort distance, force to balance the load for 12.5 centimeter, you do the same for 25 and 50 centimeters. This is not working well. Let's save yours up a bit. It's too low. Let's put it up a bit. Okay, hang your one.
To the left.
Now, is that 12 what? 12.5?
Hey,
To balance this, the effort distance has to be 12.5. So, you're getting is different from that. Okay, get that one recorded. I'll have to check. Did you get your what? Reading for this? Decided coming up tonight. You got 5, 2. What did you get? Oh, that spring was is not right. What did you get? Yeah. The what you are using is different from this, so you will have different from those ones. So let's see. You should be finishing now with the last effort distance. We should have already recorded our findings on the activity results table we have. Your force to balance the load must be in Newton. Now, the last to do on that activity table, you have to find a mechanical advantage of the 3 efforts, and you use the formula MA, or mechanical advantage, equals load over effort. Now, your load is 500 grams. Your effort is going to be the force that you applied to balance the load. So your load is going to be, yeah, there's a space there for you to do your working out. So you can shorten it as MA equals load over effort equals what? What's your load? What is going to be the load? What's the load of this container?
500.
500 grams. Okay, over what? Over, that's your effort, C. Force to balance the load, that's your effort to balance the load. So you divide by the load 500 by your effort to get your answers. Do that quickly. Did you get your first answer? Already, yeah? Okay. Now, for the mechanical advantage, you don't write anything next to the figure that you get. You just write the number down. Don't write Newton or centimeter or whatever. Yeah. That's it. Did you find this one already? Or you did already? That is load over effort. Huh? Your load is 500. You divide it by that to get your answer. How did you get your answer to?
No, 5 meters.
I'll finish first. I have to finish. Okay, then to find this one, what did you do to find it? Load over effort. Okay, so you load over effort. If you divide it, what do you expect to get? If you divide it, what do you expect to get? So load over effort, you have your load is 500 grams over the effort. That's the force you applied to balance the load. So that is 10. So what do we get there? Okay, 50. What do we get here?
50.
That is, we say 1 here, and this one is? Okay, or you can just make your, so you have 500 by 10.
5, 10, no, 50.
50.
0, 0, bring 0 up,
Okay.
50.
That gives you 50. That's the advantage it has. Huh? Now we look quickly at your results. What you have got from the experimental activity that you have done. Now let's have, because we used 2 different types of equipment to balance, we will have Violet to give us what she got, and that should be the same with the other 2 groups. We have Carol to give us what they got. So if we can have Violet with yours. You're forced to balance the load.
The first one is 10 over.
Okay. Second,
5 newtons. And 2.
2. Now, so the other 2 who have used the same balance as Violet's group, you should have got that same one. Let's see car out.
6, 4 and 1.2.
Thank you. 1.2. Now 1.2, we round it to the nearest, we'll have 1. Thank you. Now let's have a look at your mechanical advantage. We'll have from the other group that has the same machine or same balance as Violet and her friends. Let's have it from Elisa. Raylene, please.
50, 100.
Thank you, only 1. What did you get? Paul Simon?
100.
And back to you, Brendan?
250.
250. Thank you. Let's have from Trisha. For your 6 Newton, force applied, what did you get?
8.
8. Quarry, quickly.
1.
1 for this. And Hayano?
500.
Now let's have Violet to tell us what you understand of what you have just done, the activity.
This is the formula we use to find our answer. The formula, which is the load, which is 500, divided by the effort, which is 2. And we came up with the answer 250. So what we think is that the further the spring balance is away from the pivot, the heavier the Newton is.
To sum up, class and the receiving students, when we look at our grams, the load is all 500 grams. Now, in newtons, what would 500 grams be? Equals to 5 Newton. Thank you. So, in newtons, this will be 5. Okay. So what we got here, our grams this time, you have your answers already here. That's correct. But we will make them smaller. We will make them smaller by dividing that 5 Newton by the 2 Newtons to give us the final answer. So let's see. When we divide this 10 Newton by this 5, what do we get? Okay, can I have Trisha to give me the answer?
2.
Okay, we have some putting their hands up, so let's see. Trisha says 2 Newtons. What do you say, Violet?
5.
5. Okay, let's see. Now, the second attempt, you have 5 Newtons. That is the force applied. We divide that 5 Newton by this. What do we get as our answer? Let's have Junior to give us the answer.
1.
1. Okay, let's have the last one. The third attempt, that's 5 Newton divided by the 2 Newtons. Force applied. Let's say William.
2.5.
2.5. Let's see, Gima, do you agree with that answer, 2.5?
0.4.
0.4. Gima says 0.4. What do you say? Yes, Ovin, what do you say?
2.5.
2.5. Now there is someone, Violet is putting her hands up. Maybe she wants to correct one of those. First one, okay? Let's have Hayano.
5 into 10 is 2.
Come on again.
5 into 10 is 2. For the
2.
first one.
Did you say your answer is 2?
Yeah.
2. Okay, when we divide this This is 5 Newton. Okay, 0.5, we divide that by 10. What does it give us? Trisha?
0.5.
0.5. Okay, so we should have a 0 here. Let's try that. Okay, so that is the advantage. We bring it right down to the lowest, and when we bring it down, we have the mechanical advantage for the first effort distance. Force applied is 0.5. We have the second one, effort distance, force applied is 1, and the last one is 2.5. That is the mechanical advantage. The advantage that this machine, the spring balance, had on helping us to lift these loads, 500-gram loads. Now the third summary point is just putting those two together, the first and the second summary together. When the effort distance is larger than the load distance, then there is a force advantage. Mechanical advantage is the key phrase. Our next lesson is going to be on the law of the lever, still on problem solving. Teachers, materials needed, meter rulers, plasticine, pencils. Now, meshes is the load that you are going to use. We will be using plasticine cubes and base 10 flats and longs. And with that, thank you, class and the receiving students, for your participation.
You're welcome, Mrs. Waters. And thank you for your
Okay, thank you all. You may be seated.